of my favorite backend engineers at Appsmith, Shrikant, also known as Shri. Hey Shri, how
Hey,
are you doing?
great, great. Super pumped to be here.
All right. Let's give us a couple of minutes for folks to join in, and then we can get started. All right. So people who have joined us, welcome again. Just say hello and also tell us where you are joining from. I am joining from Andhra Pradesh. It's 10:30 p.m. here right now.
Oh, I'm not in the same city, but I'm also in Andhra Pradesh, India. It turns out that it's the same time here as well.
All right. Awesome. All right. So, Sri, before we get started on this demo, I wanted to share with you a meme, a really cool meme that actually helps most of our viewers understand what we are doing actually today. So let me quickly bring up my screen and share you that. Uh, Hope you guys can see my screen. All right. So there's this guy saying, I want to make beautiful charts and graphs. And there's this other guy saying, use Appsmith and Fusion charts, which is really cool. I mean, you can build charts on Appsmith using Fusion charts. And again, he says, I wanted to use Helm charts. And this guy says, they are not the same thing. Could you explain us what this is and what exactly we are doing today?
Oh yeah, um, yeah. So I don't exactly get the nomenclature of why Helm Charts has the word charts. It works more like templates, like templates with placeholders, like fill in the blanks. So honestly, I'm not really sure, but this kind of keeps coming back in my head that there's an inception going on. Okay, you're gonna use Helm charts to deploy Appsmith, and you're gonna use Fusion charts inside Appsmith to deploy charts.
Got it.
Bad
Got
joke.
it.
Sorry.
Yeah. Credits to Dave who had created that meme internally. So all right, let's get started, folks. So, Sri, before we get started on the actual demo, I have a few questions on what we are doing today. So, I see that today we are installing Appsmith on K8s, but I wanted to also understand the different types of self-hosting methods on apps of Appsmith.
Yes, yes. So um, besides self-hosted as well, just before I get started on that, we have a cloud instance as well. Uh, which is at app.appsmith.com, which is cloud hosted. So that's managed by the Appsmith team itself. Um, but self-hosted instances, folks want to get started with something like that. We have several options uh, to get started with Appsmith as a self-hosted instance. And the reason for that is, when you're coming to Appsmith and want to install Appsmith in your enterprise, in your VPS or in your cloud, you should have to face the choice that, all right, Appsmith needs AWS to run, or Appsmith needs something else to run. No, but my company uses something else. No, that's not pleasant. So Appsmith has an AMI on AWS today. If you're on DigitalOcean instead, we are listed on DigitalOcean Marketplace. If you're on Heroku, we have a way to install easily there. We're working on getting listed on Azure Marketplace as well. So no matter what your choice of cloud is, we have a way to install there. And this is all powered by Docker itself. So we have a Docker image which is set up when you pick one of these cloud systems, and Appsmith is deployed using one of these, using whichever you choose, basically, and a Docker based setup.
Got it. All right. So, could you also tell us a few differences that we can see in self-hosted and the cloud edition?
Between self-hosted and cloud edition, uh, the differences are a little subtle. More than anything, I would highlight the difference of self-hosted instances uh, should be treated as internal assets, as
Mhm.
opposed to our cloud version, which is open to the internet. Anybody can sign up, anybody can build applications, etc. But I would stress that the point of self-hosting AppSmith would be to put it in your intranet of sorts, or a private VPC or a private enterprise network, so that one, it has access to your private databases, internal databases, and internal assets, so you can build applications that leverage those assets. And two, it's not accessible from outside the internet, so not just anybody can go sign up on your private Appsmith instance. So I would say that this is the prime difference between self-hosted Appsmith instance predominantly and cloud instance. But another bigger difference is the cloud Appsmith version runs the enterprise edition, as opposed to Appsmith self-hosted today. Almost all of them run community edition.
Correct, correct. So as a DevRel here at Appsmith, I have worked with the cloud edition of Appsmith, the self-hosted editions of Appsmith. But I'm kind of new to this, Kubernetes and K8, K8 environment. So what exactly is Kubernetes, and how is it different from the other ops based environments?
Okay. Um, Okay, that's a good question. So when you say other such house-based systems, I can't kind of think of any other thing that comes to my mind other than Docker Swarm, but I'll talk about it in a moment. I'll circle back to this. So your original question of what role does K8s play at all, and why is it? Why should I care about it? So let us say when you have when you've deployed Appsmith in your internal cloud, as well as a bunch of other applications, self-hosted, Sentry, GitLab, and a whole bunch of self-hosted applications. All of them are running Docker, and suddenly you have like 5 or 10 or 15 Docker containers running all around your cloud, and it gets hard to manage. You need to scale one of the Docker containers, and scaling that means the other containers on that server won't have resources for it, and they'll start starving. So you create a new EC2 instance and move that container to there. You're doing a lot of orchestration there with all your dozens of containers. You have to remember and note down where each containers are running, which container needs maintenance, which container needs to be updated, which container needs to be clustered. It's hard, it's error prone, it's manual. So Kubernetes kind of solves that problem, among others. So the way this solves the problem is similar to infrastructure as code, wherein you create a bunch of YAML files and dictate how you want your sorry, not how, but what. You dictate what you want to be running. You say, I want one Appsmith container to be running. I want one GitLab to be running. I want one Sentry to be running, etc., etc. And Appsmith needs so and so resources at least. GitLab needs so and so resources at least, etc., etc. We define those thresholds and we tell Kubernetes, you have to run all of these containers with these constraints on these EC2 instances. Right? I have a fleet of 10 instances. With one of them are powerful, some of them are not so powerful. Just figure it out. Just figure out where they best fit within the nodes, and run them there. And Kubernetes will handle the orchestration for you. Suddenly tomorrow you figure out that GitLab needs more resources. You say GitLab now needs another processor or 4 more GB of RAM, and Kubernetes decides, oh, I need to move this container to a bigger instance. It handles all that load for us. If one of the containers goes down, Kubernetes is able to detect that and bring it back up, um, basically automating the whole orchestration. um, so Docker Swarm also solves close to the same problem. It's also the point of that is also you're orchestrating a swarm of Docker containers, um, but it kind of didn't take off. I won't get into why and what it is, but it's also kind of solving the same problem. But it's not, unfortunately, as easy to work with as Kubernetes is. And here we are.
Correct, correct. Thanks for answering these questions, T. I hope these will help our community members too. All right. With that being said, I think it's demo time. So, Shri, I think you can share your screen and tell us how you can install Appsmith on K8s.
Yes, yes. The most fun part of the session is right here.
Folks, in case if you have any questions, feel free to drop it in the chat, and we will answer your questions at the end of the session. And I hope you all can see the screen now. Okay.
Is it legible? Is it clear? Is it okay?
Yes, yes. So we have a question on we have an early question. So it says, I never used K8s. Should I stay? Like, could you tell us?
It depends. If you've never had a coffee, would you not go into a coffee shop?
Got it. I would definitely go and try that.
All right. So I'll 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 try to put this in a way that if you haven't had previous experience with Kubernetes, also you still have something to take away from this. So if I don't sound like that, if I sound like I'm jumping over something, please point that out. I'll be happy to elaborate. That's perfectly fine. Um, just seriously answering your question. Sorry about that. So we have this. I'm going to start off with this document here that we have recently published, which is under our deploy Helm folder, which details a whole bunch of list of how you can configure Appsmith with Helm charts, how you can run it, etc., etc. But I'm not going to bore you with all this. But instead, we're just going to when there's a TLDR at the top, whoever uh, reads the rest of it, right? So we'll just start off with this, right? So Helm repo add Appsmith and the repo location and update and install Appsmith. This is basically the three commands that are needed to get Appsmith ready on your Kubernetes cluster. Um, so when I say that statement, when I make that statement, this is all the commands you need to run Appsmith, to install Appsmith on your Kubernetes cluster. That kind of assumes you already have a Kubernetes cluster. So the idea is that this best suits folks who are running their cloud already in their enterprise with Kubernetes, who are already invested in Kubernetes, or getting started with Kubernetes, and Appsmith is the first thing they're deploying, and they have a whole bunch of applications lined up. So the way we're going to do this in the demo, I'm going to create a new cluster for us, a brand new vanilla cluster, completely empty, and we're going to deploy Appsmith on it using these commands. So I'm going to come back to these commands after we create that cluster. Right, we're going to use AWS EKS cluster for this. We're going to just not register. We're going to just create a cluster here. Uh, I'm going to go demo. Well, I'm going to say this one more time. Like, if you have any questions, please go ahead. Not a problem at all. Right. So these are standard configurations. I'm not doing anything special for the session here. Um, Here I'm going to just go default security group. Select all the VPCs, all three VPCs, again default VPC, all subnets. Um, we're gonna open this for public and network add-ons, no extra specialties, and we'll just go next. Nothing extra needed. We're just gonna do vanilla installation here and create. Now, so this is gonna create our cluster. And when AWS says this process is going to take several minutes, turns out they're not kidding. It actually takes 10-15 minutes. Um, Helm charts is, sorry, there's a question apparently. Helm charts is specifically for K8s. It's nothing related to Docker alone. Um, no, actually, you're right. Helm charts is specifically about K8s, but indirectly about Docker as well, because K8s is running Docker containers underneath. So depends on the way you look at it, but Helm charts is specifically indeed about K8s. So this is going to take a few minutes. So what I did, I have another cluster ready, created exactly the same fashion, uh, completely blank cluster. I haven't done anything to it, which is created, which is active, which I created just a little while ago. Um, but but this is blank. So this is what this cluster would look like once the creating is finished and move to active state. Now we move to configuration. We have an API endpoint created 2 hours ago, etc., etc. This is what this would look like, right? There is no workloads happening other than the native Kubernetes workloads itself. These are Kubernetes orchestration workloads. These are processes that Kubernetes uses to do the container management that I described earlier. So other than that, there is actually nothing running. Um, and overview, there is no nodes. Nodes are the EC2 instances where the containers will be scheduled. And there's no nodes here, so obviously nothing is happening on this cluster. Now, next step, we're going to add some work power. We're going to add some compute to this. So I'm going to go to configuration, go to compute, and add a node group to this. What's a node group? That sounds like a very fancy and complicated term. You'll know exactly what it means once I show the configuration. It's kind of counterintuitive, but you'll see. You'll see exactly what I mean by that. Let me save it Helm demo 1 node group, ng for node group, and then select IAM role, just the default one, and just leave the rest of them as is. So AMI, Amazon Linux, there's not a whole lot of choice there. Capacity on demand, instance types. So T3 medium and T2 medium are they're slightly different, but they're kind of the minimum. They're kind of the recommended size. Oh yeah, just give me a second. Yes, is it better now? Sorry. Um,
Yeah.
so T3 medium and T2 or T2 medium, they're kind of the recommended size for running Appsmith self-hosted. Now you'll see folks running Appsmith on much lower configurations. Um, One, it'll run fine. Two, it'll actually run much better if you're not running MongoDB and Redis and have offloaded them off to someplace else like Elasticache, MongoDB Atlas, or some other thing, and are only running Appsmith server. Oh, then it'll run on Micro also, I think. But if you're starting off, you're running Appsmith with one of the standard installation methods. T3 or T2 medium is usually the recommended capacity. We'll leave the disk size as 20 GB, and minimum we'll just come up with one node. Desired is one, minimum is one, and maximum is two. And we'll go ahead and next. Excuse me. Subnets, all three of them, and we go next. And yeah, that's all. Then you create a node group. This actually finishes quickly enough, but I still have another one just in case this takes a whole bunch of long time. We have another cluster which is also created the same way, but it also has a node group attached to it, also configured and created the same way. And that node group created this node for us. Since we set the minimum count of nodes to 1 and desired count also to 1, we have exactly one node here, right? Which is of T3 medium, was created an hour ago, and is ready. Right. So we have one node, one compute node, but we don't have any workload running. See that these are just the kube system services. There is actually nothing of value running here. These aren't managing anything. So now we'll go change that. So now I'm going to switch to my terminal here. So I have my kubectl configured. I have my kubectl installed, which is the command I'll use to manage Kubernetes cluster itself, essentially do stuff on Kubernetes cluster, on a given Kubernetes cluster. And I have Helm also installed, which we'll use to essentially follow these instructions. All right, these two are, by the way, these two are installed with brew installer. There's no fancy download sour down to get this. So now I'm going to do, so how this works is, how do I put this? So how this works is, actually, like this user has pointed out in the chat, Helm relies on Kubernetes and Kubernetes relies on Docker containers. So Helm is going to talk to Kubernetes. It kind of talks to Kubernetes itself. So it's kind of like using kubectl. And kubectl will talk to the cluster, which is what we created on EKS just now, right here. So, so what's missing here before we start running Helm commands is we need to connect our kubectl command to this cluster. This is a cluster that we just created, and there's a whole bunch of clusters. There's Helm demo, there's Helm demo 1, there is Helm demo 2. So we need to tell our kubectl command that, dude, this is the cluster you need to work with. Like, I tell you to create a pod, you do it on this cluster. Right? I tell you to destroy a pod, you do it on this cluster. This is the cluster you need to be working with. So the command we need to issue for that is this guy. So this is an AWS command. This is an AWS EKS command. If your Kubernetes cluster is on something like GCP, Azure, or some other place, those guys will provide you a separate command, custom command that comes from them, which you can use to configure your Kubernetes, configure your kubectl to talk to that cluster. Since we're using AWS EKS, we're going to use this command, update kubeconfig. That'll configure our kubectl. So I'm going to set the name of the cluster to this guy. Um, so once I run this, we see that it was added to Helm demo 2 was added to kubeconfig, and now I can use kubectl. Kubectl get nodes. So this command will list the nodes that are there on this cluster. Now you can see there is exactly one node listing out of this. And if we see this one here, you see 172.31.29.22, 172.31.29.22. That's the exact node that we got in the output here. So this confirms that yes, our kubectl is indeed talking to this cluster and not any other cluster. So now we can start our Helm processes. So we're going to go here. Now we have the cluster ready. We have a cluster we can work with. Now we're going to play with Helm and Appsmith. Right. So I'm just going to copy this command here. The best way to run and experience stuff, the most advanced technology out there, copy paste. So what this does is Helm locally maintains a list of repositories. Now, repositories sounds like it's a very complicated bunch of GitHub repositories or Git repositories or something. No, it's more like a list of links. That's what it is. When you treat that as a list of links, list of bookmarks, you say, oh, I'm adding a bookmark. This is the title. This is the link. That's all there is to it. So just add that and has been added to your list of repositories. Nothing else has been done. So if I say Helm repo ls, I see that there is this one that was added. And then what's the next command? I think it's update. Yeah. Helm repo update. This command now will actually go see what the hell is there on this line. Like you've added a repository. Now this command will go see what the hell is even there. Right? While we grab the latest from your chart repositories, successfully got it from stable Appsmith chart repository, and update is complete. Now, if you had like 3 or 4 more repositories added with the add command, this would have updated all of them, and you would see like 3 or 4 successfully. Seeing 3 or 4 success messages kind of lights up my day, but anyway, we only have one today. So, right. Did I finish this? Yes. Helm repo update is finished. So now we're going to go back to Helm install stable Appsmith, and this guy. Now notice that so far we haven't done anything on the cluster, itself. So if I go kubectl get pods, we won't see anything. Right? No resources are found in the default namespace. Now even in our cluster from the console, you go to workloads, nothing is happening. Nothing so far has happened. Now, excuse me. Now the moment I do Helm install, this is going to add resources to our Kubernetes cluster, whichever is the current connected cluster is, which is our cluster, and basically add the Appsmith pod to it. Now let's see how that goes. There is. So a couple of warnings, but that's fine. So this is the name of the pod that was name of the service that was created. And was deployed, just now. Status is deployed, revision 1, etc. And we get a bunch of nodes here that tell us how we can reach this instance currently. Notice that, okay, I'll get to that. So these are instructions on how we can reach our instance. But before that, let's just go see what changes have occurred here. So if I go to overview, there is this one node. And if I go to workloads, there is just these 3. I hit refresh, and you see that there is 4 now. Appsmith 1 dash etc. And if you see, that's what this name is. Right? There is a new workload that was added on our cluster a minute ago, and this is one desired. It's only one desired. It's zero ready. So these guys are all ready, but this one is still not ready. So you can get the status from here as well. So you say cube CPL pods. Uh, we see that this one is still running. Oh, it's running. Sorry. Oh, it's running. So this should actually change state very soon. If it, so the idea was if it wasn't running already, the state would have shown pending. But since it's already over 60 seconds, it's already moved to running. Um, yeah, awesome. So we have this up. So we'll just go. So we'll just go try and access it now. So we have get the application URL by running these commands, right? So I'm just gonna copy these and paste it here. Yeah, sorry for the movie there. All right. There it is. So now we have a local URL setup that's on your locally on your system, where the port for 8080 on your local okay, port 8080 on your local system is forwarded to port 80 on the Appsmith pod on the cluster. So now the Appsmith instance running in the cluster is available to you on localhost 8080. It's not available outside of that. So you don't have to be worried that, oh, it's already up and it's already out in the internet. So is it already open to attacks? Well, no, it's only open locally. So you can go HTTP localhost 8080. We do that, and there it is. Our own fresh Appsmith instance is bang on. So I'm gonna go sign up. Shri right there. Transfer. Uh, Engineer, and next make your first tab, and there it is. This is your very own Appsmith instance. Does that did it make sense so far? Questions, comments, anything?
I don't see any questions though, but I think there will be a few at the end.
No problem. If there's any questions, like you can speak up or drop a message, whichever is fine. I think you can speak up. I don't know if folks can join and talk. But anyway, so so I just created an application and dropped this here, right? Um, Now I'm going to show something else then. So we'll try something else. So down here, if we go, there's a whole bunch of configuration parameters that are available, right? You can change something. Say for example, you change storage class, the container name, image itself. You can change the image itself. Um, but I want to show one of these Appsmith MongoDB URI, right? So there is this Appsmith MongoDB URI. So this is what I was saying earlier um, when you say, um, okay, there's a question. So would this replace using say Docker for self-hosting? Would this replace using say Docker for self-hosting? So please correct me if I misunderstood this question. So you're asking if this would replace the current way of installing Appsmith, which is purely by Docker and not via Helm or Kubernetes. If that is the question, then I think no. I think both have their separate purposes. Uh, okay, I think both have their separate purposes. So okay, one of the things is that Kubernetes uses Docker underneath. So these two are not competing with each other in the sense that they're working together with each other. So the role of Docker is that we tell Docker, okay, For Appsmith to run, I need a little sandbox, and in that sandbox, I need a Java process to be run, I need a MongoDB process to be run, and I need the file system to have these bunch of files. So I'm describing what I need for my application to run and how the sandbox should look like. This is what Docker is solving for me. And that's the extent of what Docker solves for me. Now, what Kubernetes does is, okay, you have your container. That container is running whatever shenanigans inside it, whatever nasty stuff is there inside that sandbox. I don't care. You have this container. Docker is managing that container perfectly fine. That's okay. Now, you just tell me, what does this container need in terms of compute resources? It needs 2 GB of RAM to be available. It needs one dedicated processor. It needs to be accessible on port 8080 or port 80. It needs network resources of so much. It needs to be clustered. You tell me what this needs in terms of compute. I don't care if it runs Java. I don't care if it runs Python. I don't care anything at all about what it's actually doing inside. This is Kubernetes role. And what Kubernetes does with this information is that, okay, let's take stock of inventory. I need to run 2 of these containers. I need to run 3 of these containers, and these containers need so much resources. These containers need so much resources, etc., etc. It takes stock of all the inventory and then sees what kind of power does it have available. Do I have one server? Do I have 10 servers? Are those servers powerful enough to accommodate all of these containers? Are those servers, is one server powerful enough to run all these containers? It tries to fit all these containers within these compute resources, within these nodes, basically. Once it figures that problem out, it'll say, okay, Docker, dude, come here, run this container on this node, this container, this node, this container, also this node, etc., 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 etc. And then Docker will go into that node, sit down, see how that container needs to be run, what processes need to be run inside that container, and just manage that container, do that container's stuff, and not care about anything else in the world. So Docker runs your applications, Kubernetes manages Docker itself, in a way. Did I make sense, or did I sound like I went into a tangent?
Yeah, I think it's pretty clear.
Uh, Please feel free to post another message if that didn't make sense, or if you want me to elaborate on something. So Kubernetes is suited when considering scaling beyond a small single instance. Yes, yes. I mean, technically you can use it for a small single instance also, but why? Like, that's if you're already very comfortable with Kubernetes, and like you feel easier to deploy even if it's a single instance using Kubernetes. Why not? Like, sure. But if you're scaling beyond 3, 4 containers, yeah, you seriously should consider Kubernetes, or managing your containers will quickly become painful and error prone. I can personally vouch for that.
Yeah,
All right, awesome. Um, okay, if there's any questions, please go ahead. I'll interrupt what I'm doing here because this is beyond what I planned for, so it's fine. Right. So what I'm going to do is the Appsmith that we installed just before in the demo earlier, that contains all the necessary services needed for Appsmith to be running, right? So it has the Java backend server, Nginx for serving the static assets. It's running MongoDB. It's running Redis. Yeah, I think that's all that it's running. So excuse me. So the exercise we'll do, I'll show here now, is we'll use MongoDB outside of this. We'll use an external MongoDB. So this is what I mentioned earlier. So if you split MongoDB outside and use something like MongoDB Atlas, then maybe you'll be able to run Appsmith with lesser resource machine. Maybe T3 micro or T3 small is enough. You don't need T3 medium. Yeah, sure. So we'll do that. We'll do that experiment here. Right? So the way I'm going to do that is I have a clustered silly mock cluster deployed on my MongoDB Atlas organization. So there is this guy. So I'm going to use this MongoDB database um, to deploy my Appsmith. So now I'm going to deploy Appsmith using Helm Charts, um, but it won't use a MongoDB internally of that belongs to itself, but it will instead connect to this MongoDB cluster and store all its data. Right. So I'm going to show browse collections. You can see that there's a bunch of dummy data here, mock dummy collections here. But once we're done with installing Appsmith that uses this MongoDB cluster, we'll see an Appsmith database here. We'll see an Appsmith database here. So I'm going to just close these two. They're confusing. Uh, so we're going to go here. Now we see. Okay. I'm going to come back here and close this. And I go Helm ls. This will list all the applications currently installed and being managed by Helm itself. So which is basically one application, right? And the status is deployed. So I'm gonna, in the interest of, because I'm switching the whole database itself, I'm gonna uninstall and install and start fresh because new database, you're anyway losing everything. Might as well. So Helm.
Shri, could you just scroll your console just to see what you're typing? Because I think your name is obstructing the terminal.
Oh, thank you so much for that. Good point. I'm just genuinely trying to do that. Whoa. Oh, there it is. Thank God. Okay.
Yeah.
Okay. So I'm gonna go Helm uninstall Appsmith. This will make this go away. Helm. Oh, sorry. Helm uninstall. The name is not Appsmith. The name is this guy. Right. So I do that, and then this will go Helm uninstall this guy, which means Helm will go tell Kubernetes, okay, this application is apparently no longer needed. You can do away with not having to run those containers, right? So there. So now this is gone. So now if we go kubectl get pods, we won't see anything. Nothing is there. We can go confirm that here as well, right? In the workloads, you see that Appsmith thingy is here, and if we refresh, that's gone. We're back to 3, right? So that one is gone. So now we're going to do Helm install again. Helm install, this install command. Now I'm going to do this a little differently. Instead of using a generated name, I'm going to give it the name. Right? This is going to be the name of the Helm installation. So the name here, this guy, the name here will turn out to be just Appsmith now because I'm not asking it to generate a name. I'm giving it a name, but we're installing the same thing essentially. And then we go set. We go. No, not here. Where it's. So provide how to do that here. There it is. Options can be set with -- set persistent storage class this guy. So I'm going to copy that here, and I'll change the variable I want to set is this guy, MongoDB URI. I'll copy this whole thing and paste it. So the MongoDB URI, I want it to point to this MongoDB database that I have here. So I'm going to go back to the overview tab and click on connect. Oh, let me zoom here as well and realize. All right. So I'm gonna go connect with MongoDB shell and copy the URI here and put this in. Now we're going to change the database from my first database. We're not using silly names here. We're using serious mission critical names. Now Appsmith. Here I need to put in the username and password for this. We have demo user, password for this, and the complete URL. Right. So now Appsmith that's about to be installed will use this as the endpoint for storing all user data, application data, etc., etc., etc. So there we go. So the difference we'll notice here from the way we installed it before is that now we'll see an Appsmith database created in this collection in this in this cluster, which should be soon once it comes up. So we go kubectl get pods. We see that it's already running. Oh, okay. Um, let's just give it a few more seconds and refresh. Okay. We can look at logs here. kubectl logs follow um, Appsmith 0. Appsmith 0 comes from here. Sorry, wait. Right. So Appsmith 0 comes from here, actually. So it's the name of the pod. So when you get kubectl, get me the logs of this pod, and it'll get you the logs of whatever is running in that pod. Um, so the follow is just, print the logs and then keep following for whatever new stuff that gets going into the logs. It's like tailing. Right, it's still coming up. Okay, let's go check it out again. If I refresh the database, there it is. That's the Appsmith collection. It contains all the pages, applications, users. Even I mean, it'll be empty. Obviously, nobody has signed up on this instance because it's brand new. Probably can go check that out also. Right? Why not? Come on. All right, there it is. So I'm going to copy this instructions to access my Appsmith instance again and watch this silly movie of typing stuff. All right. Okay. So we have our new Appsmith again available at localhost 8080. Essentially the same fashion. I'll close this tab, open another one. Localhost 8080. And there it is. So get started. Shri, and we go here, project, first tab. See, now that I am here, I'm signed up. I'm signed up as this user. So if I go back to the database and the users collection, I hit refresh, which should be somewhere around here. I hit refresh. Oh dear God, that's refreshing the whole thing. Okay. I go user. Oh, there it is. See, my user is right there. So this is the database now Appsmith is currently is now using. It doesn't have an internal MongoDB of its own anymore, and it can run on lower amount of resources, should we choose to. But the database is now living elsewhere, MongoDB Atlas. That might mean some latency depending on where your MongoDB Atlas database is hosted and where your ECAS is hosted. Like for instance, in my case, this is hosted in AP South 1, I think. Yeah, AP South 1. And this database is located in, I don't remember. This database is located in also AP South 1. So there'll be minimal latency. This should be fine, but just something to look out for. If it turns out that these two are on either ends of the world, maybe you'll see some latency where every database call will need to traverse half the planet. Yep. Um,
All right, that was so cool, Shri. So, folks, in case if you have any questions, feel free to drop them on the chat. I think it's pretty straightforward on how you have demoed, connecting Appsmith to an another new MongoDB instance, which is like pretty cool.
yeah. Yeah. I mean, there's lots more options here that you can play around with. I would encourage you if even if you're just starting out with Appsmith, starting out with Kubernetes even, try this out because Helm Charts was recently released. And I'm seriously looking for feedback on how to improve it. I have a few things lined up to improve the experience already. Uh, More the better.
Right? Rory says, thanks for the walkthrough.
Thank you.
All
I
right,
can
folks.
entertain any questions like
Yeah, so we'll wait for a couple of minutes to take any
yeah,
questions, or else we'll end the call.
yeah.
All right. So this recording will be available on our YouTube. In case if you want to go back, watch on how you can install Appsmith on K8s, this will be available on our YouTube channel. Alternatively, if you have any errors or issues, you can come hop onto our Discord where Shri and other folks will be super active there and can help you with your installation process.
Oh yeah, you guys should seriously join Discord. You're missing out a lot of fun crowd, dude.
Right. All right, guys. I think we'll end this call. With that being said, we have two more events lined up for the next week. So we have our developer advocate conference who will be talking on Hasura's event, the API and data show. So conference will be demoing how you can build internal tools for e-commerce applications on Appsmith using Hasura as backend. And on 20th 24th of February we have an event with Elasticsearch. So our co-founder Nikhil will be demoing how you can build internal tools using Elasticsearch as the backend. You can sign up on luma/appsmith. I'll drop you that link on the chat. Alternatively, you can come hop on to our Discord and see all our events listed there. All right, let me just drop you the documentation for Helm Charts as well. All right, I have just shared the link where you can sign up for our upcoming events. Shri, could you also take us through the documentation for Kubernetes for a quick second?
Um, Sorry, documentation for Kubernetes itself.
On Appsmith, I mean, like installing Appsmith on Kubernetes.
Yes, yes. Just give me 1 second. Um, I'll pick it up. There it is.
All right.
Should I drop it in chat?
Yes, that should do.
Yeah, I think I
Okay.
dropped it in the right place.
No, I'm actually
Okay,
sharing that on the chat.
okay.
Cool.
Thank
All
you.
right, folks. Thank you for joining us. Thank you, Shri, for taking your time and explaining how to install Appsmith on K8s. And I hope you'll come join us really soon to also discuss the other cool things that you will be working on. So take care, folks. We'll be
Yep,
dropping off. Feel free to join our Discord in case of questions, and this recording will be available on YouTube. Thank you all.
awesome. Thank you guys. See you.